Everyone, golf is a science built on a single critical moment. Let's imagine Tiger Woods, a player who can carry the ball over 280 meters. What if he swung without maintaining lag? How much distance would he lose? I analyzed this mathematically from an engineering perspective. Without lag, his carry distance would drop to around 130 meters. Similar to hitting a 9-iron. Unbelievable, right? Today, we will break down exactly why lag has such a massive effect. A golf swing is a highly complex, three-dimensional motion involving more than 14 rotational joints. Vertical forces, rotational forces, inertia, and the elasticity of the club all interact. Analyzing all of these at once is extremely complicated, so we will focus on the most influential variable, lag. Golf experts often explain the secret to maximizing clubhead speed through two key concepts: the whip effect and the double pendulum motion. However, the commonly mentioned double pendulum motion only explains the hinge behavior. It does not account for acceleration, joint limitations, or energy transfer. As the radius decreases, the angular velocity increases. But this alone does not directly increase head speed. In reality, forces that are not perpendicular to the direction of the club's motion actually reduce head speed. Gravity also has a minimal effect. Because gravitational acceleration is only 1/20th of the downswing acceleration, the whip effect comes from the law of conservation of energy. As the same amount of energy travels down the whip, the thickness of the whip gets thinner toward the end. Because the tip has less mass, its speed increases dramatically. The same principle applies in the golf swing. Energy flows from the body to the arms, and finally into the club. So when the sequence is efficient, the club head accelerates like the tip of a whip. So instead of discussing abstract principles, we will compare the motion itself, which makes it much easier to understand. Ideally, swing analysis should be done using calculus to account for real acceleration. But the process is complex, so we will simplify the analysis with a few assumptions. First, we model the swing as uniform circular motion in a two-dimensional plane. Second, we assume that the hands rotate at a constant speed. Based on Tiger Woods' real impact club head speed, his hand rotation speed is about 126 RPM. We will compare the swing with lag and without lag, using the same 126 RPM. The comparison interval is the final 30 degrees before impact, which lasts only 0.0396 seconds. In this brief instant, the distance traveled by the club head determines the final speed. Case 1 with lag. The club head rotates additionally beyond the hand rotation. The head travels 2.113 meters in 0.0396 seconds. This results in a head speed of 53.4 meters per second. And with a smash factor of 1.5, the ball speed becomes 80 meters per second, producing a carry distance of about 280 meters. Case 2 without lag. The wrist angle is released early, causing the club and arms to rotate together. The head travels only 1.256 meters in the same time. This results in a head speed of 31.7 meters per second and a ball speed of 48 milliseconds, producing a carry distance of about 130 meters. The difference is shocking. Even with the same rotational power, lag increases club head speed by 68%, adding about 150 meters of carry distance. This is why many amateur golfers struggle with distance. They create wrist cock, but they release it too early, losing lag long before impact. If your current ball speed is around 48 meters per second without lag, proper lag can increase it to 80 meters per second. The effects of lagging go far beyond just increasing speed. Lag is not only about power, it's the key to creating the optimal impact for every club. For all clubs except the driver, the lowest point of the swing must be in front of the ball to produce a proper forward divot. To move that lowest point toward the target, you need two things: hand first and weight transfer. You can shift the low point with either one, but only by combining both hand first and weight transfer properly can you achieve the most efficient swing. In this video, we'll focus only on the hand first movement. Lag is the essential condition that makes hand first possible. Without lag, hand first impact simply cannot exist. Why? Let's take a closer look. In circular motion, the lowest point lies directly beneath the center of rotation. A swing without lag follows a large circle centered on the torso, while a lagged swing transitions from that larger circle to a smaller one centered on the hands right before impact. Here's the key: without lag, the clubhead's rotation axis never moves away from the body's center. But with lag, that axis starts from the torso and shifts toward the hands before impact, enabling a true hand-first position, because the hands move forward as the head drops due to lag. This naturally produces a clean, forward-leaning hand-first impact. This position allows an iron-down blow, reduces fat shots and topping, and guarantees the precise front divot every pro wants. Lag is a physics-based requirement for generating distance and producing a proper strike. In the next video, we will analyze how to create lag using ground reaction forces and how hip rotation synchronizes with arm rotation to generate maximum swing power. Make sure to subscribe and like so you don't miss the next breakdown.